Assalamu alaikum students. My name is Osama Anis. I'm the new lecturer of Mechanical Engineering Department at NID University Karachi. I will teach you CLO3 of manufacturing process 1. And in CLO3, I will teach you regarding the joining technology. In joining technology, there is one topic today which I will going to explain. This is fundamentals of welding. And fundamentals of welding, I will explain you regarding overview of joining technology. What are the parameters, components used in welding process or in joining technology? What are the different types of joint welds present in the during the welding process, or what kind of joints we can weld together? And the physics of the joining technology or physics of welding. In physics of welding, I will cover two concepts: power density and heat balance. Power density and heat balance. Um, First, I will explain the difference between the joining and the assembly. What is assembly? Assembly is a very simple thing, is a mechanical fastening method. For example, if you have two plates, one and two, you can join these two plates temporary with the help of bolt, with the help of screw or nuts. The temporary joint has one advantage: we can easily separate them, dismantle them if you as per our requirement. And as far as joining is concerned, joining will produce joining process through joining process. Permanent joint is produced, and the one disadvantage of joining processes, we cannot easily separated these two plates. We have to break the junction join we have to break this joint. These two plates are welded in joining process. uh, from here, I will mark it with the help of red color. This is one joint point, and this other one is this joint point. This joint point. And in joining technology, we have some processes called welding, soldering, and brazing and adhesive bonding are the example of joining process. It's a very big scope, but in our course, we will only study regarding the welding, soldering, and brazing. These two parts, when this is the matting surface of two parts. In matting surface, these two parts are come in contact. Matting surface sometimes also called the fanning surfaces, and these two fanning surfaces will come in contact, and joint will form at the junction of these fanning surfaces. Junction, or you can say it is a joint. Joint joining process will perform here at this junction and this junction, and we can join permanently both parts with the help of welding, brazing, and soldering. First, I will explain the welding. What is welding? Welding, it is a material joining process which used to assemble two or more parts permanently by the application of heat or sometimes with pressure. Many welding processes are accomplished by heat alone, like in fusion welding. Fusion welding is a process of welding, a type of welding. Fusion welding is a type of welding. And in fusion welding, there is no pressure required. Other weldings are to be done by a combination of heat and pressure. And in some welding processes, only pressure is required to fuse two parts. No heat is required there, right? And the parts, these two parts, when we weld these two parts together, these two parts in welding called base metal, because these two parts are going to be joined. And what happen in welding, heat is applied at this point by electric arc, and due to this heat, these two surfaces will melt and fuse together. And they come in actually they are in already in contact, and when we uh, provide heat at this point or at this junction will melt due to high heat, because uh, like this electric car will produce a heat of around 500, temperature will be around 5500 degrees centigrade, which is high temperature, or which is a huge temperature to melt any metal. And to make this joint stronger, filler material is added during the welding process, here and the other end and at the other end. When these two parts fuse together or solidified together after welding, the this whole assembly will called weldment. Because before welding they were the separate parts, there were the two separate parts, but after welding it will be a new assembly, and that assembly will called weldments, because welding will be done to join these two parts. And one more point, when heat is applied at this point, when heat will apply at this joint, right, molten pool will form. What is molten pool? Because the surface of this plate and surface of this plate are in contact with each other. When we apply heat, both surfaces will melt and form a weld pool. Weld pool means a fusion zone where base metal are in a molten state, right? Then I have this a very good picture here, and you can easily get an idea. These are the different joints. This is lap joint, corner joint, butt joint. I'll explain in later what are these three joints. So we have more joints. Uh, these this part and this part are called parent metal. Parent metal means base metal, and after solidification, this orange part or this orange thing will form at the junction or at the fusion zone, and this will be called weld bead, right? There are some advantage and disadvantage of the welding. Actually welding form a permanent joint, but there is one disadvantage of this permanent joint. We cannot easily separate these two base plates, one and two. We have to break them with the help of a force. But in assembly process, we assemble two plates with the help of the bolt, and we can easily dismantle them without any breakage. But if you want to open these two parts or dismantle these two parts, you have to break the joint. Material will waste. Material will be wasted in this process. Um, the other advantage is the joint strength is very high as compared to the base strength of base metal, because all the metals have their own UTS, ultimate tensile strength, and when these two parts fuse together they form a bond, and they form a joint will form, and that joint is typically as high strength as the strength of base metal. It is more economical process, and but disadvantage is that this process will require skilled labor, and that will cost um, this process as high cost, because skilled labor is required. Is a very delicate process. Welding is a very delicate process, so high labor is required, and so cost will be high. What is the history of welding? In the past, blacksmith, they had the profession of welder, or they were the welders, like blacksmith are they were the welders, and they used to join two parts by pressure welding. And what they do, they had one furnace, and they used to place vital one in the furnace, and they heated this part till the plastic state. Plastic state means the material will not regain its shape. Again, they lose all the elasticity. And if they heat this part till 5,000 degrees centigrade temperature in the furnace, and they used to heat this part till this part went into the plastic state. After that, they took out this part from uh, the furnace and placed on the table, and this table will call the anvil. And they had another part two, and they used to join these two parts together with the help of hammer. What they do, what they did, what they used to do, they used to combine this part with the help of hammer. They used to place these two parts, part 2 and part 1, together and apply a hammer. And they used to do hammering till both parts are fused together. They perform pressure welding in this manner, like they have one furnace, they used to heated this metal till its plastic state, and then they took out this metal from the furnace and joined this heated part with the other unheated part with the help of hammer. So this is a very old conventional pressure welding process. But now, uh, with the passage of time, new technologies came into the world, like fusion welding, solid state welding. I will explain these all welding types later in this topic. The first thing is types of welding process. What are the types of welding process normally are using currently in mechanical engineering? The welding processes are different types. Like there are so many types of welding. Fusion welding has actually has four types, common four types, like arc welding, gas welding, resistant welding, energy beam welding. These four are the types of fusion welding. Fusion welding is the type of welding process, but fusion welding has also four types: resistant welding, energy beam welding, gas welding, and arc welding. And all the weldings has their own different types, like arc welding, sheet metal arc welding, flux core arc welding, tungsten arc welding, and plasma arc welding. Gas welding has oxyacetylene welding. Resistant welding has three main types: spot welding, seam welding, and the projection welding. Energy beam welding has two types: electron beam welding, laser beam welding, right? In fusion welding, heat is produced by electric arc, and due to this heat, melting will occur. Melting will occur. But in solid state welding, no heat is required, only pressure is required to join two or more metal parts. And solid state welding has three types: precision welding, fusion welding, ultrasonic welding. One more special type of welding process is soldering and brazing. Soldering and brazing are commonly used in electronic industry, and usually these two processes are performed at low temperature as compared to the other fusion welding and solid state welding.
There are three main components used in welding process. Number one is film material, number two is flux, and number three is electrode. Basically, all these components are related to one thing, which is electrode. Filler material are filler materials are used to fill in this space where these two parts are joined at this point at the red junction, and filler material is added to this joint during the welding process. It will melt along with the surfaces, and because the main function of the filler material is it provides strength to the joint. Number two is the flux. Flux is normally coated on this filler material, and during the welding process along with the filler material, this flux will melt and deposit on the joint along with the filler material. This flux will also m- melted and deposit on this joint and form a slag. Slag will prevent this surface from impurities. And the other function of the flux is flux will provide this surface of this joint from oxides, because when heat is provided to this junction or to the fanning surfaces will melt and comes in the molten state. And molten state, there is a chance that this molten metal will react with the outside atmosphere oxygen and form of oxides, because oxide is harmful for this joint because it will create a porosity over the surface over the joints, which will ultimately affect the weld quality. So flux is a cleaning agent used to avoid the contamination over the welded joint. So flux material is usually used as a preventing or cleaning agent, because it will prevent this surface from to form oxide on this surface. Because oxides, one other thing is that if oxides are formed on the joint, it will erode this surface or it will form corrosion over the surface, right? Corrosion is a uh, process, is a rusting process. You can say is rusting, corrosion. Number three is the electrode. This is the main component of the welding. Main component of the welding. Most important component welding. Because during the welding, there's this workpiece. These two are the workpiece, and we call it a base metal. And electric arc will produce between electrode. This is electrode. Electrode will conduct electricity, right? And due to polarity, because sometimes there is a chance like reverse straight polarity, I will explain it later. This anode, this electrode is positive anode, and this base metal is anode, right? And due to polarity, electric arc will create when this electrode comes in contact with this base metal. Arc will generate, and due to arc, heat is produced, and this heat uses to melt this base metal. And when this base metal melts, they fuse together and form a joint. This electrode is it has two types: consumable electrode and non-consumable electrode. Consumable electrode means, I have explained you, like it is a filler materials is also a electrode. Filler material is also called is also a electrode because during welding process it will melt and deposit on the joint. Also is a solar material, as I've already explained you, like it is also used as a source of filler material, and it is mainly used as shielded metal arc welded. Sometimes if you read the manufacturing books, you come across with the word bare metal. Bare electrode. Bare electrode means there is no flux. Flux is not coated on the filler material or electrode, right? Bare electrode. Bare electrode. Bare electrode, it doesn't contain any coating, and to in that case, we will provide a shielding gas, and this shielding gas will prevent the electric arc as well, which will produce between the electrode and the base metal. It will also um, save the base metal, molten base metal from to form oxides. Shielding gas, if we use a bare electrode. Non-consumer electrode, it is not consumed during the welding, and filler material will be added separately. I have explained, well, this is electrode, and filler rod or filler wire will be added separately. eh, Will be added separately during the welding. And this gas extinction arc welding, in this welding type, non-consumer electrode will be used. We have some different types of welding positions. This is a rectangular workpiece. This is rectangular workpiece, and if we want to weld over this surface from left to right, and this surface welding position will called flat position. And if we want to weld vertically from bottom to top, it will call position will call vertical upward. And if you want to weld from top to bottom, it will call vertical downward, vertically down position. And over this surface, you want to make a joint, or you want to weld this surface from left to right, this is called horizontal position. And under this part, like below the flat surface, there's one more surface called overhead. If you want to, like, if we have two parts, this part, right, and this surface, under this below surface called overhead overhead position, right? It is very important if we talk about the electrode, um, if you want to talk about the electrode nomenclature. It will come in the next topic. This is the electrode welding nomenclature. In normally market, we have so many electrodes, and there is a number mentioned on the electrode. This is electrode, and on normally electrode will be recognized with the help of one number. For example, you have 013 is pasted or printed on the electrode, and you will recognize which type of electrode it is. We have some nomenclature. E stands for electrode, and the other two digits called minimum tensile strength. It will represent the minimum tensile strength, right? Like 60 kilo pound per square inch, or sometimes it will call 60,000 pounds per square inch, right? The other two digits in the this digit, this after the, like, this fourth digit will represent the position of welding. If it is 1, then you can use this electrode to weld in all positions. And if it is 2, then you can use this electrode in flat position and horizontal fillets. For example, you can only weld over this surface, and you can use this material on this surface only, right? The the other two digits, like if we combine these two digits, like 1 3, right? The last two digits represent the coating, which is normally on the filler material. This coating, I will shade it with the help of blue color, and this blue color will represent the coating applied on the electrode. This 1 3 is coating material, right? And sometimes you will find two more digits like EXXXXA1. Sometimes there you can see, or you will find, like after this five digits numbers, 5 digits or five places, after the 5 places you have one hyphen and another, and after this hyphen you will see two letters will be written on the electrode, and it will represent the mixture or material which is present in the coating, or present in the coating means present in the flux coating alloy material, right? These are the nomenclature, or you can easily identify what kind of electrode you will use, or you are going to use to melt the, or to weld the two parts. We have some types of weld joints, like number one is butt joint. If two parts lie in the same plane, you want to join these two parts on this junction, this is called butt weld, or butt joint. And if you have two parts, and you want to join these two parts at the corner, like one part is in the horizontal plane, other part is in the vertical plane, and you want to join from this corner, this is called corner joint. And if you have two parts lie in the horizontal plate but overlapping each other, this is called lap joint. And if you have one part in the horizontal plane, another part in the vertical plane, and this vertical part will be at right angle to this horizontal part, then it is called T joint. The last part is the H joint. Like in H joint, two parallel surfaces will be joined. Like if you have this two L type parts, and this is fanning surface and this is fanning surface. If you want to weld these two parts, you will form this H joint, right? Normally in practical, we like you can perform this weld joint welding, corner joint, lap joint, T joint, and this edge joint. You can easily perform in NED university manufacturing lab or in fabrication lab. You can easily form all these five types of joints in the weld by using arc welding or fusion welding process. Now you have types of welds. The previous topic is related to joint, what kind of joints or what are the different types of joints we have in welding process. Now we have types of weld. Number one is fillet weld. What is fillet weld? Fillet weld is normally used to join T, lap, and edge joints. Like if you see, this is, you can say, L joint. An L joint you can weld only from this surface. Only one fillet is required. And if you want to make a corner joint, you can make from this surface. You can weld this part with the fillet weld. And if you have two parts like lap joint can be welded with the two fillets will be required to weld this part. And for T joint also two fillets will be required to join these two parts, part 1 and part 2. And this blue part in welding process called base metal, as I've already explained you in the introduction. Number two is the groove. Groove weld have groove weld has three types: V, U, and J, and bevel shape. If you see these two parts, part one and part two, and you want to join these two parts from middle, like groove joint usually used to weld edge joints and the butt joint. You can form butt joint with the help of groove weld. And this V, U, and J means if you have two plates like this, if you have two plates, one plate is like this and the other plate is like this, and if this is V type, and you can fill out or you can melt this surface and this surface, this surface and this surface, you can melt the both surface and fuse together and add filler material, then weld will be called groove weld. This type of weld will called groove weld. Similarly, if you have one part like this, another part is like this, then you can join with the J type, and filler material will be added, right? Number three is the plug weld or slot weld. Plug weld or slot weld will be performed to join two flat plates. If you want to join two flat plates, you can, or the you if you want to make lap joints, you can use plug weld or slot weld. Like, you don't if you have an options, two options, you can join from this surface, you can join from this surface. But if you have two holes over the plate, you can join with the help of the slot weld. You can fill out this filler material inside this hole and join it. This is slot and this is hole. The other thing type is spot and seam weld. Spot and seam is resistance welding type of weld. Spot weld and seam weld, this is separate type of welding. And if you have two plates like this and this, you will apply pressure from here and here, and nugget will form, one spot or one small hole will form here, and these two parts will be joined. This is seam weld. Like seam weld you will see in oil canes like Habib oil or Tang. All these canes like Tang and oil canes will be welded with the help of seam welding. Seam welding is a continuous welding process. If you see, you can you can make circular parts with the help of seam weld, or flat parts as well you can weld. Number five is the flange weld and surface weld. In surface weld is not used to join two parts. Like if you have plate like this, and if you want to fill out this surface, you can only add filler material over this part and fill out this hollow surface. This is called surface weld or surfacing weld or surface weld. And if you have one vertical flat part and the other one is the L-shaped part, then you can make a flange weld. Flange weld means you can weld from the top. Like if you have one part like this, like so tilted or slanted, the other part is in the other shape like this. You can fill out this part with the help of filler material and form with the help of filler material and form flange joint. and form flat joint. Like in joining process, we have so many features of fusion weld joint. Fusion means like molten. S- Fusion means in molten state. If you have this plate and this plate, right, plate 1 and plate 2, like in 3D it will look like this. In 3D it will, if we look from this surface like this, and the other part, if you look from the front surface, if you weld these two plates together, there is three zones will form. One is heat affected zone, other was fusion zone, and one is original structure. Original structure means the structure before welding, right? Or the structure where no weld is formed. During welding, this surface and this surface will melt and form a fusion zone. Fusion zone means molten pool will form here. Here, molten pool will form with the help of the heat or by the application of heat, and this molten pool will also called the fusion zone. And in fusion zone, filler material is also added to make a strength or to give a strength to this joint. The this dotted line, the a region between this fusion zone and this dotted line is called heat affected zone. Heat affected zone is not a fusion zone, and in this zone no molten or no melting will occur, but due to fusion zone or due to welding temperature, in fusion affected zone, grain structure, microstructure of this base metal will change. In heat affected zone, in heat affected zone, microstructure microstructure of base metal will change due to welding temperature. Due to welding temperature in heat affected zone, base metal microstructure will change, right? And temperature will be very high in fusion zone, right? In melting zone, the temperature in this area, in green area, temperature will be very high. In fusion welding, normally it is 5500 degrees centigrade, which is enough temperature to melt any material.
We want surface and want to melt the surface, and the power is required, heat intensity is required to melt this area or to melt the surface, and that is called that is called heat density. Heat density or heat energy supplied to the fanning surface, and resulting temperature are sufficient to cause localized melting of the. Localized means only where we want to join these two parts. Like if you have this area and the other plate you have, if you want to join this part as well, localize means on a concentrated area. Localize meaning. And power density is the energy required to transfer to the surface to melt it per unit area. Like it is the power or it is the heat energy required to transfer to the workpiece per unit surface area, and its unit is watt per mm square, or in fps unit is British thermal unit per second into inch square, and a is the surface area over which the heat energy is transferring. Have different welding have different power densities, as you can see in this chart: oxy fuel welding, arc welding, resistance welding, laser beam welding, electron beam welding. All the weldings have different power densities. There is one numerical.
Regarding power density, we can solve it. I will explain you. A welding heat source is capable of transferring 150 BTU per minute to the surface of a metal. There is one metal surface, and 150 BTU power, 150 BTU per minute is transferring to this surface. We can convert it in second by dividing this 150 by 60, and power will be we have power is 2.5 BTU per second. This is power density. This is power required to transfer to the surface of a metal. The heated area is approximately circular. This is the heated area, which is circular, and the heat intensity decreasing with increasing radius. This heat power or intensity will decrease with increasing radius. There is two concentric circles. One has 0.25 inch and one has diameter zero point 0.1 inch. Both are the concentric circles. Like one circle has an zero point 0.1 inch diameter, the big one is 0.25 inch diameter. 50% of the power is transmitted within the circle of diameter 0.1. 50% power will apply will transfer to this circle, and the remaining 75% is transferred within the concentric diameter of 2.25 inch here. What is the power density? We need to calculate the power density, and power density has a formula: power transfer per unit time to the surface divided by the area A. And what is area? Area is the surface area over which the energy is transferring. As you can see in our practical, energy is transferring over this surface, this circular surface, the circular surface. So first we need to find out in part A the 0.1 inch diameter inner circle, and circular part diameter is pi by 4 d square, pi by 4.1 whole square. We have 0.00785 inch square will be the area of first circle, and 50% of heat is 50% of power is applying to this circle. So multiply this power, 2.5 BTU per second multiplied by 0.5, and we have 1.25 BTU per second is applied to the smaller circle. Now we have we can calculate power density. We have power and we have area. Power is 1.25 and area is 0.00785, and power density for the smaller circle will be 159 BTU per second into inch square. This is the power density for the smaller. Now we can calculate for the bigger circle. As you know, this is a concentric circle, right? These are the concentric circle. So we can 159 BTU power density is power density of this circular area, and we need to find the power density of this area, right? This circular area. So we minus the area, bigger area from the smaller area. Pi by 4, 0.25 square minus 0.1 square, right? Answer we have 0.0412 inch square. Now we need to calculate the power transfer to this bigger circle. Power and 75% power is transferred to this surface. 75% power is transferred to the surface, and I will calculate this. As you can say, 50% is applied to the surface, and then 75% apply to the bigger surface. 75%, so 0.75 minus 0.5, because 50% is applied to it, and the remaining will be transferred to this area, this bigger area. So 0.75 minus 0.5, and this multiply by 2.5, and we got 0.625 BTU per second, right? And now we can find out the power density. We have power, we have area, so we can find out the power density, which is required to transfer to the surface to melt the unit area. P over A, 0.625 divided by area is 0.4012. In power density, we have 15.16 BTU per second into inch square. This is the power density required to transfer to the bigger area, and this is the power density required to transfer to the smaller area. Now there is one more thing, is heat balance in fusion welding. Heat balance in fusion welding. Now I will explain regarding the heat balance in fusion welding. Like the quantity of heat required to melt the material to a given volume is UM. UM is the heat required or heat used for welding, and this will depend upon three parts. Is the volumetric specific heat of material. The second thing is melting point of melting point of material or metal. The third thing is fusion heat. Fusion is the heat of fusion. It is the heat. It is the heat required to uh, melt the metal from solid to liquid state, or it is the heat required to transform to the metal to convert it from solid to liquid state. That is the heat of fusion, and it is directly it has a direct relation with the with the heat required heat energy used for by the welding operation. There is a one heat source in welding operation. Heat source, it could be electric current. It could be electric current, and because due to electric current, heat is produced, and as you know, all the heat will not use to will not use to transfer to the workpiece. Some of the heat will loss, and it will incorporated by a factor F1, and when the heat is transformed to the workpiece, so one part of the heat will use to melt the metal, that is UM. As I have already told you, UM is the amount of a quantity of heat required to melt a material per unit volume, and the HW is the net energy used by the welding operation. Like, this is an energy, it is only used to transfer to the workpiece. This is only used to transfer to the workpiece, that is HW. And HW has a unit joule in SI unit, and FES is British thermal unit BTU, and UM is the unit energy required to melt the material per unit volume, that is joule, and a unit of UM is joule per mm cube, and BTU per inch cube in FPS system. and V is the volume of the metal melted. It is a volume of the metal melted in, we can take it in mm cube. As you know, the volume of the metal is mm cube or inch cube or centimeter cube. This is the another relation between the HW and UM. If we study this heat transfer with respect to the time, then RH will introduce in the equation. It is the rate of heat transfer to the work surface, to the workpiece, and RHUM is the rate of heat required to melt the material, right? And F1 and F2 both are the heat loss factors. One is the heat loss factor in transferring the heat to the workpiece. The other is the here heat loss factor in melting the material. Actually, both the heat transfer units, heat transfer factors, it is the ratio. The first one, F1, it is the ratio of the actual heat received by the workpiece divided by the total heat generated at the workpiece, right? And the other heat transfer factor is F2, which is also called the melting factor. It is a proportion, or it is the part of heat received at the workpiece that can be used for melting, that can be used only for melting, right? F1 and F2. F2 is called F2 is called melting factor, as you can see, and F1 is the heat transfer factor, because during heat transfer, not all the heat is used to heat up this material, right? Some of the heat will loss into the environment, right? That is the heat transfer factor, F1. The and the heat transferred to the material, this heat will use to melt this part, this blue part is used to melt this part, blue part, right? That is UM. And there is one more heat melting factor, and as you know, not all the transferred heat will use to melt this material. Some of the heat will lose inside the material, and it will goes into the HAZ, and it means it will go the this loss heat will goes into the heat affected zone. This is the heat balance topic in fusion welding. The other one is the welding as commercial operation. There are many applications of welding. Welding is used in a construction of ships, airplanes, aerospace industry. Pipes can be welded. Pressure vessels where the gas is stored is also welding process will use. Seam welding process will use to weld the pressure vessels. Shipbuilding, aircraft industries, welding processes can be used or are used in commercial operations. Uh, welding operations also use a skilled labor, as I've already explained you, and the person who has a profession of welding called welder. And fixture or device, it is a device used to clamp the workpiece, because we need to clamp the workpiece or the two parts which are to be joined. These two parts are held in a fixture. That fixture is called welder fixture or welding fixture. The last thing, welding positioner, a device that not only holds them but also move the assembly. Means it kind of some trolley or something like fixture is placed in that positioner, and you will move from this positioner. You can move this positioner left and right, right and left. You can move it, right? The last thing is automation in welding. Like we have machine welding. Like in NAD University, we have you can perform manual welding with the help of machine. You have transformer, electrode holder, And in machine welding, high skills high skills are required in machine welding. And automatic welding, there is a regulator, and there is one machine, and on that machine, this machine has one regulator, and through this regulator you can control the electric arc. And robotic welding, it is uh, widely used in uh, automotive industry like BMW, Mercedes, Audi. They are using robots to weld the automobile frames. They are using robotic welding. You can A robot can weld automatically the frame. They can weld spots. They can weld seams. These three are the welding: machine welding, automatic welding, and robotic welding. These are commercial weldings or automation in welding. Number The last thing is the welding safety, because welding will be performed, or welding operate processes are performed on high temperatures, and fused metals are used, uh, and these things are very environmental hazard and dangerous for the human health. And high temperature arcs are harmful for the body. So some safeties are normally used in the welding lab. uh, Welding gloves, welding proper clothes are used during the welding process, which are necessary to use, because health, safety, environment organization are created some SOPs for the welding process, because welding is dangerous and process for human and for environment as well. Because during welding, when metal will weld, and molten metal, during welding, some fumes will elaborate from the material, or normally elaborated from the material, and these fumes are not good for human breathing. So you can see a head here. You can see a helmet. Actually, this welder wears this helmet, and there is one probe, and this probe is normally connected to the air filter, right? And this helmet is a specialized helmet, and it contains air filter, which, because during welding, normally obviously people, like welder are like all the welder beats. So uh, there's a chance they can, or he can breathe harmful substances, or harmful fumes he can breathe. So there is one filter to avoid this to harmful fumes. And one more thing, you can use exhaust, stationary exhaust, like normally we exhaust use in kitchens. So this exhaust, stationary exhaust, will be used in the, or normally used in the welding or fabrication shop, to protect the breathing from welding fumes. Gloves and protective clothing like rubber gloves and protective clothing, especially rubber slippers or rubber shoes, will be used or should be used during the welding operations. These are the safety which are required during the welding process to protect the human body.